The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees.
Well, good morning. God, I'm amazed we got this many people on a Wednesday morning. I'm impressed. I was Director of Technical Services for Central Ready Mix here in Milwaukee for 10 years, from 1995 to 2005. So I'm just going to profile two projects that reflect my personal experience in developing high-performance concrete. One of these is on, and I'm sure you all read your April issue of Concrete International, Notable Projects. One of these is in there. Of course, you do. Yeah. That's two of you. Very good. I put all that together. This is the cover of ACI's 2004 Centennial Celebration of Concrete. And they chose the Milwaukee Art Museum as the most iconic structure they could think of to put on the cover. I tend to agree. This was the most difficult concrete project I've done in my life. And I've been at this for a few years. Very complex structure, very complex form. I mean, it's really not a structure, it's a sculpture. Designed by Santiago Calatrava, who's a maniac and extremely demanding, but very complex formwork, extreme rebar congestion, oddball shapes. In fact, the formwork, we joked, it wasn't formwork, it was cabinetry. They had their own woodworking shop on site. Project went way, way, way over budget, came in way, way, way behind schedule. But this is how we do it in the 20th century. Odd everything. Everything was different on this. Bucket and crane, crazy shapes. While you're in town, if you get a chance, go over and take a look at it. It really is something to see. Again, the lot with the bucket and crane, but also a great deal of pumping. And here's where we get into the concept of 20th century high-performance concrete, all superplasticized. But understand that, up until very recently, 301 said the maximum slump for superplasticized concrete coming out of the truck is 8-inch. So after it goes through the pump, it's maybe 6. So we're very reliant on this guy right here with the vibrator. And I always joke that the guy with the vibrator is the guy that showed up late for work that day. There's no real classification of vibrator operators. But a lot of rebar congestion, a lot of odd shapes and sizes. So, obviously, every single mix in this project was developed for this project. And this is that cantilever. That's basically the guts of the building. A 35-foot cantilever. This is heading east practically over the lake. It was pumped. We did the first half of the ring beam. It was just under 300 cubic yards. It took 13 and a half hours to place. And I know because I was there for every minute of it. That's me. We were checking every single load. And this is one of the problems with 20th century superplasticized concrete, because we were using the old melamines and naphthalines. So that meant you had to have your water content and slump very precise leaving the plant so that it would arrive at the site ready to dose, because these are site-added materials. And so it just adds a whole new layer of effort to what you're doing. Achievable, but slow. And this is what we wound up getting. I mean, it was a very successful project, but it was just an extraordinarily difficult one. This is one of those projects that everybody involved hated every minute of it until it was done. And then there were several parties afterwards to celebrate it. We were all constantly high-fiving ourselves because of what a great job it was. But it was miserable building it. This gives you an idea. It's really neat, so if you get a chance, go take a look at it. It was a neat job. This is the ring beam, the western portion of it, tying into the supports for the walk bridge across Lincoln Memorial Drive. A little bit of a side. This is the entrance to the parking garage. It's the neatest parking garage in the country. It's really cool. That's actually a better picture of it. That should have been on the cover of ACI's book. But anyway, I actually took that photograph when I was on the project. I was on the site of the other project when I took that photograph, and I'll get into that a little bit more. Inside of the building, so don't just drive by it. Go inside and walk around. It's really a beautiful building. But you get kind of an idea when you look at this as to how difficult it is to place this kind of concrete. This is the parking garage. Again, beautiful, beautiful parking garage. So before I got into really getting into ultra-high-performance concrete 21st century, I get a call from a contractor, and this is really how things advance. It's not all, when you see all these esoteric presentations here at ACI on all the minutiae of concrete or cement chemistry, and what really comes down to is a superintendent saying, how the hell am I going to do this? And that's what happened here. I got a call from the same contractor that did the Milwaukee Art Museum. And the superintendent said, I've got these architectural columns, wood grain formliner, no access to vibration, a 20-foot free fall, which ACI says, maximum 4? So I suggested this SCC technology, which we'd never done before. This is like 2004, 2005. This is what we had. If you can see here, partially formed up. We have a 2.5-inch access to place the concrete. And again, this all gets into the dark recesses of the architect's mind. Gee, it looked good on paper. I suggested SCC. Got a commitment from the contractor that he wouldn't break my knees if it didn't work out right. So we go back to the lab, and a concrete lab is not pharmaceutical. It isn't a bunch of people with white jackets and test tubes running around. We're mixing mud, and my standard was a 1.5 cubic foot sample. And that way we could do 8, 10, 12 mixes in a day. And we dial in a mix that looked like it might actually be concrete. So then we get that figured out, and we put 5 yards in a truck. And in this case, what we're trying to do, we've got our little mock-up here, and we're going to free fall our concrete, see what happens. Not exactly the scientific method, but now it worked. Now what's important to note here, self-consolidated concrete's not a new concept. It's been around since before I was born. That's what the contractor assumes that 100-gallon side tank is for. What happened with SCC, if you do this with water, you don't see coarse aggregate. Do we have coarse aggregate here? We can see it. So we know we have a self-leveling material that's holding the coarse aggregate in uniform suspension. So we go to the job site. This didn't all happen in one day, by the way. And it wasn't anything real involved, just a forklift and a bucket. And this is what we placed. Now understand, this is my first attempt at self-consolidating concrete. That's probably about a 22-inch spread. If I were doing this today, I'd probably do a 28-inch, maybe greater. Milwaukee's blessed with excellent, excellent aggregates, so we can really push the envelope. But this was the first attempt, and this is what we got. This is the public market. It's in the April issue, notable projects. That's how it turned out, no vibration. I personally think it's uglier than sin, but the architect thought it was beautiful. How you look at that as a mock-up and say, oh yeah, let's do this again. But the form staple is reflected through, so as a concrete producer, it's good. And originally the architect, knowing that he was assigning the contractor an impossible job, had specified a light sandblasting of all the columns to even out what he assumed was going to be a very uneven appearance. Saw this and he said, no, everything's fine, leave it go. So now I'm pretty confident. I know how to make SCC. So I get a call from another superintendent. Jack, how am I going to do this? 2 fish tanks. This is down on the lake shore. This is about 200 yards south of the Art Museum. A saltwater tank and a freshwater tank. 22-foot free fall. And the wrinkle that made this difficult were these fiberglass form ties for corrosion. They didn't want to use metal ones. And we looked at them, the contractor and I, we both said, these cheesy little things are never going to hold up. And the architect said, oh yeah, no problem, they're great. So I suggested SCC. Now this is partially formed up. You can see why the contractor was concerned as to how he was going to place this. Because there's, a little bit of rebar in this. And we've got this block out for the glass tunnel that will go through the fish tank. So the architect, he was from out of town, I think he was from Seattle, and he specializes in fish tanks. So the contractor submitted SCC, and the architect said, no good. I've never heard of this. I don't trust this. I don't know this. So I'm just the ready-mix producer. And, of course, if you're the ready-mix producer, anybody in here that is, you're at the bottom of the construction food chain. So the contractor was so anxious to use it, he made up his own formwork, his own mock-up, to bring by my lab so we could do a mock-up. And at the time, I didn't even know what an ASTM box was, because SCC wasn't being used in the field that much. I've since become very familiar with them. But we poured the concrete from the top down, sawed a piece off to send out to Seattle for the architect to look at so he could see aggregate gradation. See, a lot of people assume, mistakenly, that the most important ingredient in concrete is cement. And it's not. Cement's evil. It causes all kinds of problems. We want to use as little cement as possible. It's glue. Sand, it's filler. It doesn't contribute to anything. We have to have some. So what we really want is, we're trying to recreate stone. So we want as much stone as possible. But it's important that it be kept in suspension, uniform suspension. You've all broken cylinders in your life. That 7-day cylinder, you take the mortar to failure and it breaks around the aggregate. The 28-day cylinder, we want to see it shearing through. We want to take the concrete to failure of aggregate. If you don't have aggregate, you don't have good concrete. Based on that, if you can see, we've got perfection. And this is about a 28, 29-inch flow spread. And now we're ready to go. We're all set. I was actually standing on top of this with my camera, ready to go and get all this flowing concrete recorded when those fiberglass form ties stepped into the picture and started failing due to the increased head pressure of the SCC. And of course, the form ties are going off like rifle shots. And so all of us up here got religion in a hurry. So we immediately had to stop the pour and figure out what are we going to do. So we quick huddle on the job site. Of course, this is the type of stuff you don't hear about here at ACI. We're starting the project. We're 4 or 5 feet into this form. We've got to do something. So I said, okay, tell you what we're going to do. Normally with SCC, you do not want to do lifts. The preferred method is just start with one point and let it go. So what we're going to have to do here is do it in lifts because these form ties aren't going to hold. So I called the plant. I said, send every 5-gallon pail of non-chloride accelerator. And we started dosing NCA on the site so that the lifts individually would gel a little bit quicker so we'd have bridging strength to put another lift on top without overly challenging the form ties. It worked. So we continued the job, about a half-hour interruption. Mostly still pumped it, but used the crane and bucket. And this is what we placed. You don't have to wonder where the coarse aggregate is. We can see it. Completed structure. Just painted. No rubbing. Zero. This is inside the fish tank looking out. That is not cladding. That is black paint. That is white paint. The fish are quite impressed. That's what we got. That's what we had. No vibration. First time for this contractor. It wasn't like we had a lot of experience with this, but it's very, very achievable. Completed structure. If you get a chance, by all means, go look at the Art Museum and understand that that was miserable to build, and this was a walk on the beach. 4 years apart, but a century apart.